Start a new page here. So that's it for section 1.1. Now let's do section 1.2. All right, which again, we're not going to finish today, but we need to start on anyway. Gotta catch up, not fall behind. All right, so section 1.2, right? The title of this one is Linear Equations and Rational Equations. Linear equations and rational equations. I think it's kind of weird, actually, that the textbook lumps rational equations in with linear equations in a single section, because studying rational equations is a lot more complicated than linear equations. So it's kind of weird that they kind of lump it in here, but they kind of simplify the process, and they're only going to show us a particular type of rational equation, but whatever. So now, so our first subheading here is solving linear equations in one variable. Linear equations in one variable. It keeps falling off the edge over here. Sorry about the handwriting. Okay, so we're going to start with the definition. All right, I mean, what even is a linear equation, right? So a linear equation in one variable is an equation that can be written. So it can be written. Not every linear equation will be in this particular form, but can always be, it is always algebraically equivalent to this form, I'll say, right? That can be written in the form a times x plus b is equal to 0, right? So every linear equation could be put in that form where a and b are real numbers, right? With a not equal to 0, right? Fair enough. So why do they say with a not equal to 0? Well, it's kind of just covering a stupid case. If a were equal to 0, right? Well, then we'd have 0 times x plus b is equal to 0, right? Which would just mean that b is equal to 0. So it's kind of a stupid case, right? So if you're a linear equation, then you have that whatever that constant is that's being multiplied by x, right, cannot be 0. Okay. All right. So that's what a linear equation in one variable is, right? There exist linear equations in 2 variables and 3 variables and infinitely many variables. It's still a linear equation, right? So this is a linear equation in a single variable x. Okay. All right. So we already know what a solution to this is. So I don't want to define that again. We already know what the solution set is. Let's talk about 2 equations. Okay. 2 equations with the same solution set are said to be equivalent. Okay, said to be equivalent. So why do we care about that? So, right, because we're going to be doing arithmetic to equations to make them simpler, right? And as long as you do the same thing to the left-hand side of the equation as you do to the right-hand side of the equation, you get an equivalent equation. It's going to have the exact same solution set. So you're able to simplify this equation into something that's equivalent and easier to solve, basically. Oh, say that one more time. 2. Yeah, TWO, yeah. That looks even worse. Okay, let's see. All right, there we go. That's beautiful. Okay. All right. So good. So now we have equivalent equations. So for example, 4x plus 12 equals 0, right? That's a linear equation, right? Okay. But this is equivalent to, right? I'm just going to write a double-headed arrow here, right? So this is equivalent to, I could divide both sides by 4 if I wanted to, and I get that x plus 3 is equal to 0. If I divided both sides by 4. Okay. Yeah. And that's just a little bit easier to solve. X plus 3 is equal to 0. Because now I can subtract 3 from both sides of the equation, and I get that x is equal to -3. Right? So all three of these equations are equivalent to each other. They all have the same solution set. Right? Fair enough. The solution set here is -3. Right? Fair enough. Remember, the curly braces just mean I have a set, and then I'm just going to write down all my solutions inside of there, right? I only have the one solution, which is -3. Okay. All right. So I claim that all three of these have exactly the same solution set, right? -3. If I plug -3 into this equation, I get 4 times -3 plus 12, which does indeed equal to 0. So it's a true statement. If I plug -3 into this equation, -3 plus 3 is equal to 0, which is a true statement. So then if I plug -3 into this equation, I get -3 equals -3, which is a true statement, right? So they all have the same solution set. Okay. So that's how we're going to solve equations, by writing equivalent equations that are just easier to solve. Okay.